given 5 matrices A, B, C, D, and F, and we need to show that all of them are invertible. We know that a matrix S, for instance, is invertible if its determinant is not 0. So, to show that all of these matrices are invertible, we need to show that the determinant of each of these matrices is not equal to 0. So let's start with matrix A. The determinant of A equals the determinant of 1, negative 1, 0, 1. Again, it's 2 by 2 matrix, so to find a determinant we need to multiply these two entries and then subtract the product of other two entries. So it equals 1 times 1 minus negative 1 times 0. So it's 1 minus 0, so just 1. So the determinant of A does not equal 0, which means that A is invertible. Now we will do the same for matrix B. The determinant of B equals the determinant of 2, 3, 1, 5. So it's 2 times 5 minus 3 times 1, which is 10 minus 3, which is 7. So again, the determinant of B does not equal 0, so B is also invertible. Well, the determinant of matrix C equals the determinant of 1008, which is 1 times 8 minus 0 times 0, and it's 0 minus it equals 8 minus 0, so just 8. So the determinant of C does not equal 0, so C is invertible. Great. Now the determinant of matrix D. Well, it's a bit more difficult because matrix D is 3 by 3 matrix. So I will copy paste it here. So let's review how to find the determinant of 3 by 3 matrix. We will do that using the expansion of the first row. So when we do the expansion of the first row, we take the first entry of the first row, which is 2 in this case, and then we multiply it by the determinant of the matrix, which we get by ignoring the first row and the first column. So we multiply it by the determinant of 4, 3, 4, 2 matrix. Then we do the same with the second entry of the first row, so it's minus 0 times. Now we will ignore the first row and the second column. So it's the determinant of 1, 3, 5, 2 matrix. And then we need to add the third entry of the first row, so negative 1 multiplied by the determinant of matrix, which we get by ignoring the first row and the third column. So it's 1, 4, 5, 4. Well, let's do the calculations. So it's 2 times 4 times 2 minus 4 times 3 minus, so 0 multiplied by the determinant of this matrix is 0, so it's minus 0, minus 1 times 4 minus 5 times 4. Well, let's do the calculations. We get 4 times 2 minus 4 times 3 is negative 4. Negative 4 times 2 is negative 8 minus 0, and here we have 4 minus 20, which is negative 16, minus negative 16 plus 16. So this equals 8. So the determinant of matrix D is 8, so D is invertible. And finally, the determinant of matrix F equals, let me copy paste matrix F. So the determinant of matrix F, again we will use the expansion of the first row, So here we have 2 times 1 times 2 times 1 times 3 minus 1 times 0 minus -1 times 0 times 3 minus 2 times 1 and plus 0. Well, let's do the calculations. We get 2 times 3 minus 0, so 2 times 3. Here we have minus -1, so it's plus 0 minus 2, so it's minus 2, and plus 0. So we get 6 minus 2, it's 4. So matrix F is also invertible.